Hello, I'm Hugh Manfield, and welcome to my science channel. Now today I'm going to be talking about artificial gravity. Now what do I mean by artificial gravity? That's gravity that we can control, we can turn it on, turn it off, have it at will, as opposed to natural gravity, which we all are in right now on the Earth, which we have no control over. So to create artificial gravity, it's actually pretty easy. All you need are some rocket motors. If we had a rocket-powered football field, while the rockets are off, there's no gravity on the field. Now if we ignite the rockets, start accelerating the field, there will be gravity on the field. So how is this gravity created? Do rockets project gravitational fields that span the entire universe? No, they don't. They create acceleration in the object they're attached to. And that's the best way in understanding gravity. So if the rockets are off and someone on the field throws a football, it's going to travel in a straight line at a constant velocity. And it will continue until it hits the dome or flies off into space if you didn't have a dome. And that's Newton's first law of motion. An object will remain at rest or continue in a steady state of motion indefinitely. And that's what's going on with the football. So now, when we turn on the rockets, now the field begins to accelerate. Now, does it do anything to the ball? No, it's not in contact with the ball. But from the point of view on the field, the ball begins to follow a curve, and there's apparently gravity. And this is Newton's second law in action. That is, objects acted on by a force will change their state of motion at a steady rate. So when we look at this picture, what object is being acted on by a force? Well, the field is being acted on by the force of the rockets. The ball is not being acted on by any force. But it appears to move in a curve because the point of view, the reference frame of the field, is constantly changing motion relative to the reference frame of the ball. So it gives this illusion of gravity. Now, I've had this chart on several times. There are only three ways to experience gravity. We can have linear acceleration, which either, Einstein's man in the chest that's being pulled by a rope, or we could have a rocket motor attached to the box, or you could be on a wagon wheel space station that's in a state of rotation, and you'll experience gravity there, or you can stand on a massive object. So the question comes down to, what do these three forms of gravity have in common? Now we could call these two forms artificial gravity because we can turn them off and turn them on at will. And this third case would be what we would call natural gravity because we have no control over it. We can't start it, we can't stop it, it just goes on and on forever. Let's just take the first and third case and look a little more deeply into what's going on. The gravity felt when you're being accelerated feels exactly like the gravity that you feel when you're standing on a massive body. In fact, you can describe it all with Newton's second law, and the equations of motion will work for any object. It's like you throw a ball while you're in the accelerated reference frame, the ball will appear to follow a curve, just like it does on the Earth. So we can say both of these forms of gravity can be described by Newton's second law. And that's one thing that these forms have in common. In the first case, we understand exactly what's going on. The chest is being accelerated through space, or the rocket, or the football field, and Newton's second law is applied to the chest and everything in it, or the rocket-powered football field and everything on it, and everything else outside of that is obeying Newton's first law. Now in a massive body, we haven't been able to understand gravity in those terms. And in fact, we don't really have a good explanation of how gravity works. What's the actual physical process? Now, I know you're saying, well, Einstein invented general relativity, and that tells us all we need to know about gravity. Well, no, it doesn't. And I'll explain why later in the video. But Einstein really solved nothing. If you talk to someone who understands general relativity, they'll tell you, yeah, mass curves space, and that makes objects move in a curve, and that's how gravity works. Well, then ask them, well, how does mass curve space? Well, it just does. I mean, it curves space close to it, and that space curves the space next to that, and that curves the space next to that, so on and so on. And it's like a trampoline with a weight on it. So you're using gravity to explain gravity. How does matter actually curve space? What's the physical process involved? They won't have an explanation, and they'll just say, well, we can't really explain it, and there's probably really no physical process we could actually understand. So a conversation between someone outside of the rocket-powered football field or the chest and someone riding on it might go like this. Stan in the chest says, I'm in an inexplicable field of force that spans the universe and causes everything around me to fall downward. And I have the math to prove it. I can show it mathematically, and I can predict the path objects will take due to this force. And someone standing outside would say, no, you're delusional. You're being accelerated through space. Your gravity field is actually only in your imagination. But Stan would continue, no, I'm at rest in my reference frame, and I'm obeying Newton's first law, and there's a mysterious field of force causing everything in the entire universe to obey Newton's second law. And someone outside the box would say, no, you've got it exactly backwards. You are the only thing obeying Newton's second law, and everything else in the universe is obeying Newton's first law. Who is correct? Which is the correct point of view? Which is the path we should follow to understand a deeper explanation of the process of gravitation? Is gravity a field, or is it acceleration? Well, we've reached a fork in the road. We need to choose a path. Now remember this slide, it shows you exactly where 20th century physics went off track. And this brings me to the where did Einstein go wrong part of the video. Which path do you think Einstein chose? The man on the pedestal who always seems to be right. Did he choose the illusion of gravity, or did he choose to follow the physical processes that can be understood? Well, Einstein chose to embrace the delusion, and he built a theory. Gravity in space is a field just like gravity on the Earth. And I've chosen the alternate path to build a theory that treats Earth gravity as acceleration, just as we treat it in space. So let's look a little bit further down this alternative path. Well, first of all, what we are saying is that when you stand on the surface of the Earth, it's just like standing in a rocket or on a rocket-powered football field being accelerated through space. The fabric of space-time is accelerating downward relative to your reference frame. And at first glance, that seems to have some serious problems. First of all, it would imply that space-time is falling through the surface of the Earth. Secondly, since it's an acceleration, that would mean that the fabric of space-time is falling through the surface of the Earth at an increasingly higher rate with time, which seems unsustainable. And after all, the Earth is round, and presumably it's already filled with space. So how can we keep packing more and more space into this spherical volume that's already full? So two pretty serious problems. First thing to do in approaching these problems is to understand that when you're on a massive body, it's not like being accelerated through flat space. The acceleration vectors are going to be aligned toward the center of mass, which gives you a tapered flow, or something like a funnel flow. And we can draw a boundary where the fabric of space-time will follow that boundary and not be crossing through it one way or the other, and it forms the shape of a cone. And a cone is like a funnel. And we can know from funnel flow that there's an acceleration field within the funnel, while we can have a constant rate of volume flow through the funnel. And that solves our first problem of sustainability. We don't have to have an ever-increasing flow of space-time. It can flow at a steady state, and we can still have an acceleration within the funnel. So that solves our first problem, but we still have a pretty serious second problem, as to where does all this space-time go? Well, for an incompressible flow, the volume in is equal to the volume out, and the velocity increases the narrower the funnel gets. So you get the acceleration field and you get higher and higher velocity. But when you apply relativity, you begin to get length contraction. Just like Ricky becoming length contracted, as if she is traveling at a higher rate as she moves down the funnel. So, in this case, the volume rate out is less than the volume rate in, and it's decreased by the amount of length contraction. And in fact, at some point before the end of the funnel, the flow velocity will reach the speed of light. And at that point, length contraction will be 100%, and there will be zero outflow through the funnel. So in this case, we've solved the second problem as to where all the space can be going. If it's like a funnel, like a black hole, all the space will basically be length contracted and flow off into the fourth dimension. And this is a figure I've come up with to try to explain that a little further. Basically, we have the yellow cone, which is the Euclidean geometry of a flow field, and we have the blue hyperbolic shaped cone, which is the relativistic, the non-Euclidean geometry that will exist within the flow field due to space contraction. Now, while the yellow cone has a finite volume and cannot take any more flow inward, the blue hyperbolic funnel can have an infinite volume, and space-time can continue to flow down that volume, flow down that funnel forever. What else is going on in this diagram? Well, you can see that this shaded area, that's the amount of volume contraction at a particular point down the funnel. And this distance L is equal to the distance between the edge of the Euclidean cone and the edge of the hyperbolic cone. And it defines the volume that's been contracted at that point. And if we follow it down, that volume increases and increases and will become infinite when we reach what is essentially the Schwarzschild radius very near the tip of the cone. But we can see that this contraction is going on all the way out. And it's the volume of the contraction is equal to the area times the amount of contraction. So as the funnel gets larger and larger, the area expands at the factor of a square, while the length decreases at somewhat less than that factor. So this creates a secondary field within the gravitational field. The acceleration field gives us the Newtonian gravity. The length contraction gives us an extra little pull that is very small down here at the tip, but becomes increasingly proportional larger as we move out away from the center of mass. If you plot that contraction rate with volume as the radius increases, you get a curve that looks like this. And that curve is exactly the shape that you need. This is a galaxy rotation chart, and the dashed line here is what we would expect from Newtonian gravity and observed mass. And the line up here is what we observe. And the difference between those lines is this orange curve. If you subtract the dashed line from the top line, this is what you get. So fluid space theory predicts the behavior that we observe and attribute to dark matter. But wait, there's more. Now if we imagine space-time's flowing down the funnel, becoming length contracted, or in this case the funnel geometry has been shown at a constant length to reveal the hyperbolic shape of the funnel. But when you get down to where the flow velocity reaches the speed of light, the funnel becomes flat and you get a discontinuity in space-time itself. And that discontinuity will have a spherical shape and a spherical boundary. And the perfect sphere will be its lowest energy state. And if there's more energy added to the system, it will exhibit wave behavior. It will ring, it will be elastic, and it will have discrete vibrational modes. And that leads us to quantum behavior. So, this alternative path is suddenly starting to sound even better than general relativity, because it not only predicts the effects of dark matter, it predicts quantum behavior, and the theory folds nicely in with quantum behavior rather than blowing up when you try to apply it. At this point, I'd like to introduce the term ruach. Now, ruach is an ancient word associated with religious texts, and it has two basic definitions. First of all, the divine wind of creation, the wind of God that brought form to the void. The second definition is the breath of God, the divine breath that animates all living things. Now, both of these seem to be describing godly magic that we have no chance of ever understanding. In the first case, we might actually have a way to understand it. In fact, fluid space theory predicts these motions in the fabric of space-time that bring rise to physical particles, that bring form to the void. And fluid space theory can be expressed mathematically and modeled on a computer. I know, I've done it, and this form of ruach may actually describe a real physical process that we can understand, document, and possibly manipulate. But for now, we can understand the term ruach as an actual description of a real physical process, something that we can quantify, measure, and compute. So when you look at a gravity field, and I've suppressed one length dimension to show how it would appear in 4 dimensions here, it would appear like a torus or a rolling smoke ring. Imagine that this surface is in rotation, where it bunches up, passes through the center, spreads out the other side, and comes around again, like a rolling smoke ring. Now this form of motion will have an acceleration field down here at the heart. And if we could control this ruach, we could create artificial gravity. And I know what you're thinking. Well, wagon wheel space stations and rocket-powered football fields are great, but we want real artificial gravity. We want float pallets, hoverboards, jump gates, deflector screens, space propulsion. Okay, well, what does general relativity tell us about all these things? No, 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 not possible. What does fluid space theory tell us about these things? Maybe, possibly, there's a good understanding of how that might work. Deflector shields, it's all still out there, but at least we have a theoretical path forward. Fluid space theory takes us to a place where we can at least see our destination. How do you create real artificial gravity? Well, if you could create some sort of a ruach field that would create an acceleration in the fabric of space-time, and you put a box into that space with someone in it, and then you apply a resisting force, the person inside that box will experience gravity just like we experience it here on the Earth. If you take away that resisting force, the person in the box will be accelerated by the ruach field and will gain velocity and move off as it's being accelerated. And the person in the box will feel weightless as this happens. So this form of artificial gravity could be used to accelerate objects to a high velocity without the occupant or the contents of the object experiencing any g-forces at all. And we could turn the field around and maybe put a rocket in it. And if these accelerations are high enough, we could set up basically a jump gate where the rocket would enter, be accelerated to a high fraction of the speed of light, head to the outer solar system, where you might have to have another one of these jump gates, where it could be decelerated down to its original velocity, and then you could use the fuel on board for local maneuvering without having to use it up on your trip. And it could also shorten the trip to a matter of hours or days rather than months and years. So this gives us a basic theoretical approach to achieve something like a jump gate in like Cowboy Bebop. Here we are, we stand at a fork in the road again. Do we continue to cling to the thoughts of Einstein and keep him on his pedestal, or do we embrace something new? Do we keep living in a world that's made of 95% unknown material that we can't explain and can't find anywhere? Or do we try another path? And do we reach for those godlike powers that we've always wished we could have? Well, that's something to think about. And until next time, I'm Hugh Manfield.